The last section that we're going to cover in chapter 11 is 11.6, which is on the properties of organic compounds. I'm just going to write organics. And in the textbook, in this section, they list a few different properties of organic molecules, but we are only going to focus on one of those properties, and that is solubility. So the rest of the properties you can just ignore. Solubility is describing whether or not two molecules can mix together. Whether or not two types of molecules, not two molecules, whether or not two types of molecules can mix together. If you have two types of molecules that mix, then we will say they are soluble with each other. So for example, alcohol, like rubbing alcohol and water, because they mix together, we say that they are soluble, or they are soluble with each other, which means that you can mix them. If two types of molecules don't mix, then we say they aren't soluble. With each other. And classic example of that would be oil and water, like olive oil or vegetable oil. Oil and water, we say, wow, I really spelled that one wrong. Oil and water are not soluble with each other because they don't mix. If you put oil and water together in the same container, they just sit in two separate layers. So what we want to know when we're thinking about organic molecules, what we want to know is the molecule soluble in water or not? And the rule that you might have learned in 121, we have a saying. The rule that we have is like dissolves like. The saying like dissolves like means that if you have polar molecules dissolve other polar molecules, and nonpolar molecules dissolve other nonpolar molecules. But polar and nonpolar don't mix. So that doesn't really, like dissolves like, doesn't really answer the question, is the molecule soluble in water? It just tells us to look at the polarity. We have to be able to look at the polarity of the molecule and understand if the molecule is polar or nonpolar. So what we want to do is find a set of characteristics that are going to help us decide whether or not a molecule is polar or nonpolar. If we know if a molecule is polar or nonpolar, we'll be able to determine whether or not it's soluble in water. So molecules that are polar are water, first of all, and other molecules as well, but water is the one that we focus on the most. And also molecules that have fewer than 6 carbon atoms, and also at least one nitrogen or oxygen. Fewer than 6 carbons and at least one nitrogen or oxygen. These substances, these types of molecules, are soluble in water. Nonpolar molecules are ones that have only carbon and hydrogen atoms, no matter how big or how small they are. Only carbons and hydrogens. Or molecules that have more than 6 carbon atoms, even though it might have a nitrogen or an oxygen. These molecules are not soluble in water. Now you might be asking yourself, whoa, what if it has 6? Because we have a rule for fewer than 6, and we also have a rule for more than 6, but we don't have a rule for 6. What do we do in that case? And you might also be asking yourself, maybe these criteria are different than ones that you've heard in the past. Different textbooks have different ways of defining polar versus nonpolar, and these are the ways that are defined in your textbook. So this is consistent with the resource that you have for this class. But as you look at other resources online, you might hear criteria that are a little bit different. So what I'm going to tell you is that when you're being asked to define polar versus nonpolar, I'm going to use these definitions right here, stick to this definition right here, and try to make it as easy on you as possible. But keep in mind that you might find inconsistent information out there, and that's really just because polarity and nonpolarity is pretty difficult for us to easily predict. It's just not easy for us to come up with a clean set of rules that we can follow to determine the polarity of the molecule. So don't let it frustrate you.